I was just sent the assignment today, and I ran the questions through Google just to see what I could come up with. And case number 4 was kind of interesting. Now you'll see I've got what looks like case number 4 here, but it's a little bit different in the actual questions, but I'll explain that in a moment. What I wanted to point out is that after reading through the assignment, case number 4 seemed a little bit funny. It didn't really make much sense the way that it was worded, almost as though something was missing. And so, like I said, I ran it through Google, and I found this, a series of questions that that show that your professors, I guess, are not they're not that good at writing questions. This happens maybe once a semester. I guess they get a little bit lazy. They just grab a question from wherever. They don't want it to be easy to find the answers to, so they change it around, and they don't really bother reading the question that they're handing you or that they're expecting you to answer, and then they tell you not to ask any questions about the question. So if you didn't understand case number 4, it's not really surprising because it's not complete. And so you'll see here with the original question what the complete question actually looks like. So I'll go through this and I'll explain when we get to parts 1, 2, 3, and 4 what really should be there. Now we can still answer the questions without these extra parts. It'll just make it a little more obvious what you're supposed to do, and it'll also confirm that we do have the right answers going. So let's start into case number 4. It says, a system has two components that operate in parallel, as shown in the following diagram. Because the components operate in parallel, at least one of them must function properly if the system is to function properly. Okay, so we've got these two. There's component number 1 and component number 2. Think about them as being like on a plane. You could have 2 engines on a plane. You can fly with just 1 engine. So as long as you want things to function properly, you just need one of these. At least one of them has to be working properly. If both of them fail, then you're in trouble. Okay, so let's get back to our description. It says the probabilities of failures for the components 1 and 2 during one period of operation are 0.2 and 0.03 respectively. So the probability of a failure for engine number 1 is 20%. For engine number 2 is 3%. Then it says let F denote the event that component number 1 fails during one period of operation, and G denotes the event that component number 2 fails during one period of operation. Okay, so they're telling us that the probability of F is equals to 0.2. That's the probability of number 1 failing. So that's that one failing. And the probability denoted by G is equals to 0.03, and that would be this one failing. Okay, and then they finally, they tell us in the end that the component failures are independent. Okay, so that makes this a fairly simple question in terms of doing the mathematics. So let's have a look at parts 1, 2, 3, and 4, because we've got all of those here. Now, once again, this stuff here, A through D, in fact, that's going to show up in each one of these sections that I'm covering. This is not in your original question. So basically, they took a multiple choice question and they turned it into, a series of questions where you don't have the multiple choice to choose from. So that's fine. There's nothing wrong with that so far. Let's have a look at just question number 1 and see how that plays out. It says, what is the event corresponding to the above system failing during one period of operation? Okay, so like I said, if we were to give this the analogy of being like a twin engine airplane where you can fly on just one engine, then system failure, would mean that both of them have to fail. So if this represents a failure for number 1 and this represents a failure for number 2, then both of them would have to fail in order to show that you have system failure. So it would look like this. It would just be the probability of F, so the first one failing, and G, the second one failing. So this event, F and G, is what we're looking for. We don't even need the probability of that. They're really just looking for what is the actual event. So the first one failing and the second one failing. So the answer then would be A, but we don't have to tell them that. We just have to show them that F and G is the answer. So the first one failing and the second one failing, that is the event that corresponds to the entire system failing. Now, not having these multiple choice to select from, you might not have understood that they're actually just looking to see which, well, they do ask for which events, but how you're supposed to write that symbolically. So this is exactly what we're looking for. We just need to write out F and G. The first fails and the second fails. So that would be the answer for question number 1. Now that one's not really a big deal, and neither will question number 2 not really be a big deal that we didn't have the multiple choice, but it becomes more complicated later on. Let me show you with question number 2 what happens. It says, what is the event corresponding to the above system functioning properly? So in order to function properly, we need either one of the engines to work, or both of them work. So how does that correspond to F, and how does that correspond to G? Well, F means that system number 1, or component number 1, fails. G means component number 2 fails. As long as one of them is not failing, then we're okay. So you could just have not F. That would be good. That would be one way. If we don't have a failure in component 1, then the system would work. Or if we don't have a failure in system 2, or sorry, in component 2, then the system would work. So either one of these are okay. So what we say is that it's not F or not G. You can also write that as the complement of F or the complement of G. Now I wrote not F or not G because that's how they wrote it here, but either one of these is going to be a suitable answer, because either one of what I've got in the circles here indicate that you're going to have at least one engine working. Or not, sorry, not engine, that's just my analogy, but at least one component is going to be working. So not F or not G, F complement or G complement. That's the answer that we're looking for in number 2. Now in number 3, this is where things become a little bit tricky. The way that they worded it in the assignment question that they gave you was they said, what is the probability? What is the probability that the system functions properly during one period of operation closest to? Okay, so now it doesn't even make sense grammatically. That's already a problem. But then after that, they're missing something. This is where I first saw that something's got to be wrong with this question. They want to know which one of these actual values is closest to the probability that the system functions properly. So now that we understand that that they were referring to some values that were originally there, we can get about the business of simply just answering this. We're just going to answer this mathematically. This question, when they gave you this question, when they wrote this, or when they typed this up, what they should have done is they should have altered the wording. They should have said, what is the probability that the system functions properly during one period of operation? And that's it, question mark. It doesn't make sense to say closest to if they didn't give you any actual suggested values. Now, of course, it will be closest to one of these suggested values. Let's see which one that's going to be. They want, in this question, for us to find the probability that the system functions properly. We know that that is F complement or G complement. We want the probability of F complement or G complement, because we said that that's the event corresponding to the above system functioning properly. Okay, so how do we do this? Well, the probability of F complement or G complement can be determined by looking at the addition rule. Because the addition rule looks like this. It's the probability of A or B. That's equals to the probability of just A plus the probability of just B minus the probability of A and B. So that is our general rule that we're going to follow. So to do this, instead of A, we have not F. So right there, we're also going to have to put another complement of f. And then instead of b, we have not g, or the complement of g. So then we're going to have to add in the complement of g. Then we also have to do minus the probability of not f and not g. Okay, so we need to figure all of these out. So let's do that down here, and then I'll make some space later for what we need. So I'm not going to be focusing on question number 4 right now. I'm just doing it in this space down here. So this is, I need to figure out what not f is. Well, this is just the complement rule. The complement rule says, I'll do that over here, the probability of the complement of some event or some outcome is 1 minus the probability that that event occurs. So if you want the probability of the complement of f, it's 1 minus the probability that f occurs. Now we know that f has a probability of 20%, so this is going to be 1 minus 20%. This is going to be 80%. So we've got part of our formula ready to put in, or part of the values ready to put in. We have to do the same thing for the probability of not g. So this is 1 minus the probability of g. We know that this is 3%, so this is going to be 97%. Okay, so we've got that. Now we also need the probability of not f and not g. So that's a joint probability. And joint probabilities work like this. If you have independent events, and this is only if you have independent events, joint probabilities are nice and simple. It's A and B equals to the probability of A times the probability of B. So if I want two things to happen jointly or together, I just multiply the two probabilities, the two independent probabilities. So the probability of not f and not g is simply just equals to the probability of not f times the probability of not g. So this is going to be 0.8, because we work that out over here. That's going to be 0.8 times not g, that's 0.97. Okay, so of course I forgot to bring my calculator. I just have to pause for a moment and find that. Okay, back with the calculator. 0.8 times 0.97 equals to 0.776. 0.776. 0. I've gone to 4 decimal places with that. Okay. And so, let's see. We now have the 3 different parts that we needed from our original, from what I said was going to be the original way to solve this problem. So let's plug into that formula. So it's going to be the probability, oops, there we go, the probability of the complement of f or the complement of g is equals to the probability of the complement of f. So we've got that right there. So that is going to be 0.80. That's our first one. Plus, the next thing we have to do is add in the probability of the complement of g. So that's 0.97. And then we have to minus the probability of not f and not g, or the complement of f and the complement of g. So that's going to be minus 0.7760. Okay, so when we work this one out, again, I will refer to the calculator on this one. It comes out to be 0.9940. 0.9940. Okay, so you can see that Originally, that was one of the options. We didn't have the benefit of that, but here we can see that, of course, our answer does match up with one of the ones. And that is our answer. Well, we don't have to say A. We would just show them all of our calculations because, of course, we wouldn't have A, B, C, and D. That wasn't given to you on your assignment. So we would show them all of these calculations here. Okay, so that's our answer. The probability is 0.9940. It doesn't make any sense to worry about what they meant by closest to. They really just wanted the probability. What is the probability that the system functions properly? So we've answered that. So we're going to apply the same technique to number 4. So let me clean this up a little bit, and then we'll have a look at question number 4 and what they want from us there. Okay, so question number 4, I just cleared up this space here for us to work on, and then I realized we didn't even need any space. Let me show you what I mean by that. I just worked out question number 3, and I showed you that this is 0.8, and this was 0.97, and of course I forget what this one was. This was 0.7760, and when we worked that out, we found that the probability of the complement of f or the complement of g, we found out that that was equals to 0.994. Now look at what that is. That is the probability that the system functions properly. Now they want, in question number 4, the probability that the system fails during one period of operation. Same as before, that was during one period of operation. So the system can only do two things. The system can only function properly, or the system can fail. So we've already determined that there's a 99.4% chance that it will function properly in part 3. So the probability that we have failure, which we've already earlier on identified, is the same as the event F or G, or sorry, not F or G, this would have to be F and G. It should be easy to see that this is just going to be 1 minus 0.994, because if the chance of it functioning properly is 0.994, the remainder will be the chance of it failing. So I can already see that this is going to be 0.006. Also, you can see here that in part D, that is one of the suggested answers. So you could simply just answer it like this, and that would be it. However, if you prefer, you can work this out from scratch. F and G, having both of your components fail, that's the only way we could get a system failure. So we can work out the probability of F and G. This is just a joint probability. And because they're independent, my multiplication rule is really simple. It's just the probability of F times the probability of G. Because the general rule in your textbook, the multiplication rule, is that the probability of A and B, something and something, equals to the probability of A times the probability of B, and that's it. It's as simple as that. If A and B are independent, and they did tell us that they are independent. So that's the general rule that we're working with. So we just need to multiply our two numbers together. We know that the first one is 0.20. They gave us that at the beginning. We know that this one is 0.03. This, when you work it out, is 0.006. So that's it. That's F and G. Having both components fail is the same as finding the probability of a system failure. So that is our answer. So you can either do all of this stuff here, or you can just answer with this box up here. Either way, or both. It really doesn't make any difference. So of course, we don't have this stuff given, but it does help us understand what they meant by this question, and we can also see that we have the right answer here. So that's it for case number 4.